Hello students, welcome to this tutorial on the working for the questions 8.2, 8.3 and 8.6 on page 130 in your textbook. I did promise this video quite a while back, about last week. Apologize for the delay, however, better late than never I suppose. So we will start today with a series of videos, a series of tutorials that I want to share with you, and we'll talk a little bit more about that. So let's get into the explanations on how to work these questions. And bravo to those of you who got the answers. Okay, so question 8.2 is focusing on a crane that is lifting some cement to a height of 15 meters. Let's look at what the question is saying here. It says that a crane lifts a load of cement weighing 2,000 newtons. Find the gain in potential energy by the load of cement when it is lifted by 15.0 meters. So, gain in potential energy. So immediately when you hear gain in potential energy, I am certain you will think of this equation, m times g times h. True. But when you look at what is given to you, you are given the weight of the cement and you're given the distance that it is carried through, the vertical distance, which is 15 meters. So that might look a little different to what the equation is supposed to be, because you see mass, you see G, and you see H. But this is actually a force. Don't panic. Very simple. Because a gain in potential energy is really work done against gravity. And work done is force times distance in the direction of the force. So, since they have already given you the weight of the cement, simply use that as your force, 2,000 newtons, and then you know the distance through which it is lifted, it is 15 meters. So it will be 2,000 newtons times 15 meters, which will give you a final answer of 30,000 joules. Now, students, again, it is your understanding. Once you understand what a gain in potential energy is, you can save yourself the trouble of changing that weight back to a mass and then multiplying it by g again to just simply bring you right back to that 2,000 newtons, and then multiply it by a height or the distance here, which is 15 meters. There is no need to backtrack or backpedal. That's just a waste of time. Okay? So in the exam, you don't really want to waste time on things like that. So let's go on to question 8.3. So question 8.3 is about this girl. She has a mass of 35.0 kilograms. She's cycling on a flat surface, a flat horizontal surface, and she's moving with a speed of 6.0 meters per second. They want you to find her kinetic energy. All right, there you go. Kinetic energy, we know, is equal to half mass times the velocity squared. So simply half multiplied by her mass of 35.0 kilograms multiplied by 6.0 meters per second squared, or 6.0 all squared. So that will give you final answer of 630 joules. Now you might say to me, sir, the question said her speed. It didn't say her velocity. Good observation if you noted that. In this case, speed and velocity can be used to mean the same thing, because whilst it is not direction specific here, remember, if you're moving at 6.0 meters per second, you have a velocity. But kinetic energy and energy in general is a scalar quantity, so they're not worried about your direction, what direction you're moving, to find out, what your velocity is, or to find the speed. The speed is already the velocity. Energy is energy. Energy has no specific direction. Okay, so that's why it is safe to just simply use the 6.0 squared multiplied by half times the mass. Okay, so that's how it goes. So let's go to 8.6, the final question in the series. So you were told that a fireman has a mass of 70.0 kilograms and that he climbs a long vertical ladder, and then he moves up 5.0 meters in 12.0 seconds. Find his weight. So the first part is to find his weight. Very easy, guys. Remember, weight is equal to mass times G. and weight is the force. So that's 70.0 kilograms times 10 newtons per kilogram, which will give you 700 newtons. Straightforward. So that's the first part done. Then they want you to find out his change in potential energy. Okay, so he's on the ladder and he moves up 5.0 meters. So his change in potential energy, what will that be? And that is the work he does with his body weight against gravity. So work done against gravity, which is the same potential energy. You can use gravitational potential energy equals mass times g times h. But like I said in the first slide, you don't have to go back to bring back his mass and then work it all over again to find the weight and then multiply by the height. Simply take his weight, which is 700 newtons. That's the force right there. Okay. And then multiply that by 5.0 meters, which is the distance. Okay. And once you do that, you'll get 3,500 joules as your answer. Okay. So be very comfortable with that, guys. And the final part, C, they want you to find out the average rate of work done by the fireman in climbing the ladder. Most important phrase in that question is rate of work. And the rate of work is the same as power. So they want you to find his average power, and which simply means just to calculate the power. So what is power? Power can either be work done divided by time, or energy transferred divided by time. So that will be 3,500 joules of work divided by 12.0 seconds, and that is going to give you 291.7 watts. Remember, the 3,500 joules, we had already gotten that from the previous question, so don't be surprised by that. Okay, wonderful, guys. So this is the first tutorial on some questions there on the energy, work, and power. The next tutorial you're going to get is on machines. I already sent you a YouTube video to study on machines, simple machines. So get familiar with the names of the simple machines. But most importantly, we are going to focus also on the calculations that are associated with machines. Terms such as load, effort, fulcrum. We'll look at efficiency. Okay. So we'll also look at mechanical advantage and velocity ratio. So these are some basic calculations, terms and basic calculations that you'll be learning in the next tutorial with me. So stand by for that. This will be coming as well. Thank you very much and see you in the next tutorial.